Okay. All right. So, give me some information about a quadratic. What's a quadratic? Does anybody know what a quadratic is? What?
Four-sided.
Four-sided. Oh, okay. So you're thinking a quadrilateral. That's a four-sided figure. Quadratic function. Yes, the x squared. Yes. Okay, so quadratic function. Okay, so we have some kind of f of x, meaning we have a function that's in terms of x. And the big piece of information that we are going to be looking for is an x squared piece. Okay, now x squared is a very basic function. You will probably never see it so basic as there. Okay, you might see a more cool looking function like ax squared plus bx plus c. Anybody see that before? Okay, so this is the first form of a quadratic function that I'm going to share with you, or you've maybe seen before. So this is called, anybody remember? What kind? What?
Is it like something to do with parabolas?
It does have to do, but that's not the name of it. But we will talk about parabolas. Anybody know what this form is called?
Oh, standard.
There it is, standard form. Yeah. Okay, so there are actually 3 forms of a quadratic. We're going to talk about 2 of them today, and the third the next day. Okay, so this is standard form. Okay, now when I write an ax squared and a bx and a c, I'm kind of making a statement about the a and the b and the c. What kind of values are the a, the b, and the c? Yeah, they're just like numbers. So they're just kind of a placeholder for a number. Okay, so if I give you a quadratic equation, you might see it look more like 2x squared plus 5x minus 6. Okay, that's the way you're going to see these functions. You're not going to see a's and b's and c's in there. They're just placeholders. Okay. Okay, so let's talk about the graphic version of this. Okay, if I'm going to graph a quadratic, what does it look like? A curve? Well, that's a very broad statement. Like curve? A what? Ooh, good word. It's a parabola. Okay, you see this? Parabola. I might use the word U. Actually, that's a letter. U. Okay, but it's called a parabola, and that's an actually like official word. Parabola. Okay, so we can have a parabola that kind of looks like a U. There's the super important point of this parabola. Anybody know what that point is? Very good word. The vertex, and where does the vertex lie? The very middle? Actually, you're so totally right. Oh, you're doing some really good things with your hands. I wish I could videotape you. You're like just folding her hands. Middle, what are you doing there? What is that?
Like, where it's symmetric.
Oh, such a good word. Okay, so the vertex is right in the middle. Now, I probably wouldn't say in the middle, but it's actually the very bottom of the parabola. Okay, so if I say bottom, what's a better mathematical word? There's a word.
What was it last year?
It starts with an M.
Midpoint?
No. Ooh, wow, that's really insane. No. Did you say meniscus? Oh, that's like the cartilage in your knee. Meniscus. Okay, less cool than meniscus. Just a minimum. 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 Okay, now it is possible for the parabola to get turned upside down. So the vertex could potentially be at the top or be called a maximum. There we go, there we go. Now we're getting there, max. So it's a min or a max. Okay, let's talk about that symmetry. Okay, there's an invisible line that goes right through the vertex. It's invisible and it's vertical. Anybody know what it's called? I'll tell you. Axis of symmetry. Okay, so I'm going to make a quick blanket statement for the vertex. Okay, so a vertex is a point, right? Consisting of an x and a y value. I'm going to say that the letter H is going to represent the x value of all vertices. And the letter K is going to be the y value of all vertices. Okay, so the vertex will always be identified with an H and a K. So anytime I use those two letters, I'm talking about the vertex. Okay, very specific. H and K. Sorry, that wasn't a beautiful K. Let me retry. All right, so if we go back to the axis of symmetry, the axis of symmetry is a vertical line. So can somebody give me the equation of the axis of symmetry? X equals, good start, depends. X equals, it goes through the vertex, what?
H.
Nice, nailed it. X equals H. It'll always go through the X value of the vertex, which we just called the letter H. Okay. Okay, so those were important pieces to know about. Okay, so we're going to start graphing. Okay, and the first form that we're going to use is this form that they wrote right here. Does anybody know what this form is called? Do you notice the letters? Vertex. I didn't just make those up because I like those letters. There was a reason behind it. Yeah, it comes directly from vertex form. Okay. Why do you think it's called vertex form? Yeah, like the vertex is literally put into the equation. It is very literal, straightforward, no calculations are required to find it. The vertex is literally in that, okay? So your vertex is literally your H and K that are in that formula. Okay? What do you think that A value in the front's going to do? Oops. Hello. It's going to be what? Ooh, okay. I hear this word slope. Okay. Let's talk about this word slope. Where have you heard the word slope before? When you were doing in math class? Yeah. And what were you learning about in math class? Lines. And what kind of lines specifically? Linear lines. Straight lines. So what kind of slopes do straight lines have? Constant slope. Beautiful word. Constant slope. It is always the same. No matter where you're at on the line, it is constantly the same slope. Up this, over that many. Up this, over. Doesn't matter. Now, is a parabola a function with a constant slope? No. It changes. Depends on where you're at. If I'm way over here on my parabola, the slope is super steep. It could be almost vertical. If I'm down at the vertex, ooh, what's the slope of the vertex? Exactly 0. And then we start talking about calculus, which is super fun, but not today. Okay, so it changes. So when I say the word slope and I'm talking about quadratics, that's kind of a hairy word to use. Okay, so I might say a value instead of slope, but we're talking about the steepness, right? Okay, see what this says right here? A value. A stretch of A, so if the value is greater than 1, it's a stretch. If A is between 0 and 1, it's a compression. Okay. Do you visualize a stretch? Okay, so if I have a parabola, here's my little hands, I have a parabola. What would a stretch look like? Tall. Like that? Does that look like a stretch to you? Yeah, see, tell you what, I totally disagree with this wordage. Because a stretch to me feels like you're pulling something, right? Okay, and I feel like that, I don't know, it's just so, ugh. So I'm going to change the verbiage here. Okay, so when they talk about compressions and shrinks and stretches, we're going to ignore those words, and we're going to use Nolte words. Okay, sometimes I change things and use my own words, so sorry. You'll just have to get used to it. Okay, so tell me something. Here's my parabola, and I go like this. Tell me a good word that represents this. What's happening? It's getting, don't use compression, I don't like that word. Narrow, that's not bad. Oh, skinny. Skinny, right? It's getting skinny. I feel like this is skinny. And if I go out this way,
Wide.
it's fat. Okay, now I don't know if this offends anybody, but I'm going to use the word skinny and fat. Do you agree that that is very descriptive in the parabola?
Yes.
Okay, we're using Nolte words. Skinny, fat. Skinny, fat. Okay. So, instead of saying stretch, I'm going to say skinny. Skinny. Compression, I don't like that word. It just doesn't help me. It's getting fat. Sorry, it keeps moving. Okay, so we're getting skinny and fat. Okay, so then the next part says the H is a horizontal translation. Is that an X or a Y movement? An X. Okay, so remember that's your left or right. Okay, so X, left or right. So vertical is your Y. Your Y change, yeah. Okay, so that's either going to be up or down. I like up and down. That's so much more descriptive, very literal. Okay, let's do one. Oh, wait. There's a little piece of information that's important too. Opening up and down. Whoops. Okay, so if I have an A that's a positive value, greater than 1, what does my parabola look like? Opens up, right? So that's what they mean by opens up, so a U or a happy face. So open down, opens down, upside down, right? So you're going down. If you won't need to write that down, go for it. But that might be super obvious to you. Your call, your notes, your world. All right, I'm going to take this little function, I'm going to draw it over here. Let's see what we got. 4 times the quantity x minus 3 squared plus 5. Okay, so how do we graph this? Let's pull out the obvious information. What's the vertex? 3, 5. Everybody see where she just got that? Literally pulled it straight out. Boom. That was easy. Okay, I can draw that on a graph. So draw a little graph. 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Okay, so next question. Is this going to be an upward parabola or down? How do we know? 4. Yeah, positive A. Okay, and the 4 is going to make it skinny or fat. Skinny one, right? Skinny is 4. It's going to get skinnier. Okay, now if I draw 1 point and just draw a parabola that looks skinny, do you think that's a very accurate graph? Not really. Okay, so what I'm going to require of you is I want you to give me 3 points, and I want you to label those points because sometimes it's really hard to tell where exactly your points are. Okay, So 3 points. I got 1. Vertex is 3, 5. Okay, how am I going to find 2 more points? Start with finding 1. How would I find 1 point? 1 more point. What could you do? 3 and 5. What do you mean? The x of symmetry? Okay. Okay.
Could you do 4 times 1, 4 times 3, 4 times 5?
Okay.
Could you plug a number into the equation?
I'm not going to leave that idea. Could you do what?
Plug a number into the equation and then solve the equation.
Oh, yeah, that always works. Make a table of values, right? Let's just plug in a number. We're going to keep that thought. Okay, what's a number that would be really nice to plug in? 10?
4.
Oh, 4. Why 4? It's right next to the vertex, right? We want to be close to the vertex. The further we get away from the vertex, the gianter the number's going to get. Sorry, that was a bad word. The bigger. Okay, so pick a number that's close to your vertex. So 4 is a great number. We can do this mentally. We're super smart kids. Okay, so if I plug 4 in, 4 minus 3 is 1 squared. 1. 1 times 4. 4 plus 5. 9. So we just found the points. What was it? 4, 9. Okay, 4, 9. So let's plot that point. 4, 5, 6, 7, 8, 9. Okay, there's 1. So 4, 9. We're getting there. I need another one. 5? Just 5.
You can do 2. Wouldn't break the
2
number.
is like 6.
Oh, 2, 9. Where did 5 come from? Did I hear that wrong?
Yeah, no, I was saying 2 just to get another.
Oh, throw 5 in. Oh, I got you. Oh, wait, 2, 9, but you just threw that out, bam. How did you get 2, 9?
Because it's the reflective.
Oh, boom, I love that axis of symmetry thing. That is so simple. Let's do that. 2, 9. Boom. Done. Draw a parabola. Call it quits. Miss Nolte's satisfied with her 3 points. Okay. Is there another way I could have come about those? I'm looking at you for a reason. Do you remember what you were talking about with the, what'd you say? Okay, so you said something like 1, 3, 5. Has anybody heard that before? 1, 3, 5. Where are you getting that from? Just magically came up within your brain? Does anybody remember 1 through 5?
No.
Okay, so some do, some don't. This is kind of an interesting discovery that some people have made and some people have not made. So I'm going to share with you this discovery. You can choose to use it if you want. Okay, so 1 through 5. Okay, so remember how we were talking about linear functions and that the slope is constant, right? Okay, well, a quadratic does not have a constant slope. It is forever changing. Okay, so if I start at the vertex, the ratio at which it changes from the vertex 1 unit away is a height of 1 times the a value. Then 2 units away is 3, up 3 over 1. Then the next one is up 5 over 1. 7 over 1. See where I'm getting those numbers? 1, 3, 5, 7 are just odd numbers. Okay, so if my slope or my a value is 4, what am I going to do from my vertex? What's the slope from the vertex with my a value involved? Close, say it the other way around. Up 4 over 1. Okay, so from the vertex, you can use that slope idea only if it's 1 unit away from the vertex. I know that I said this a lot of times, but it's super important. Only if it's 1 unit away from the vertex. 1, exactly 1, not a half, not 2, exactly 1. Okay, so I can go up 4 over 1. So if I went from the vertex here and went 4 over 1, where would I land? Up 4 over 1. Boom. So the next one would be what? Up what? Okay, so it goes up by, so up 3 is 3 times 4, 12. The next one would be up 12 over 1. Remember 1, 3, 5. So the next one would be 5. 5 times 4, 20. So the next one would be up 20 over 1. See how it's getting steeper exponentially? It's a good thing I only asked for 3 points. Okay, let's try another one. Boom, 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 boom. Okay, let's use this little thing. Okay. So I might give you a worksheet, and it might say something like stretch or shrink. And so what am I asking about? Fat or skinny? So that's the question I want you to answer. I don't want stretch or shrink. I want you to tell me if it's fat or skinny. Okay, so if I have this 2 here, what is it? It's a skinny. Okay, so we're going to have a skinny. Skinny. Is it open up or down? Up, and how do I know? Positive 2, right? Horizontal translation. Okay, tell me the direction. 7 to the left. Everybody follow that? Okay, so everybody see where we're getting that? If it's a plus 7, remember the parent function is minus, so you always do opposite. Left. 7, or you can think of the vertex. Okay, vertical translation. Up 9. Up 9. So we're just strictly getting that from the vertex. Okay, your turn. On your sheet of paper, draw this function. Okay, give me 3 points and make sure to label all 3 points, please. Okay, how do we do? Did I give you enough time? Does everybody have what I have? Oops, this is for a different problem. Everybody got a vertex at negative 7, 9, an additional point at negative 6, 11, and negative 8, 11. Figured it out? Okay.
I accidentally did positive 7 instead of negative 7.
Oh, that would definitely. How many people got that right? Has exactly what I have. How many people found their mistake and is okay now? Okay, good. Did anybody find different points than that I have? The ones that I have? Because I'm not saying those are the only points. There's an infinite amount of points that are on that graph. Mine are not the only 2 additional points you could have found. Did anybody find different ones? Okay. Just be aware, though, there's more points, right? You could have given me different ones. But those are the ones I'll probably be looking for. Okay, let's try it again. Okay, let's start this one. This time we got a 1/2 in front. So, what is this? Skinny or a fatty? Fatty. This is a fatty. Is it up or down? Up. Horizontal translation. Left or right? Okay, right, how far? 4. Right. 4. Vertical. Down. 8. Everybody follow that? Okay, on your own, graph this one. And I will tell you, be very, very careful. Okay, did I give you enough time? Take that as a yes. Okay. All right, so I only got this far. I labeled my vertex. Help me out. Give me another point. Who's got a point for me? Hold on, let me tell you. Your name is Faith. Dang it. Emily?
Yeah.
You're Faith. Oh, I got you guys screwed up on the sheet track. Emily, Faith. Okay, Emily, what do you got? 5, -4. I'm going to say P, and I'm going to put a question mark. Okay, so I want to know if Emily is right. How can I check to see if Emily is right or not? Plug it in. Okay, so we can do this mentally, right? Let's plug this in. Okay, so we're plugging in which value? 5. Okay, so 5 into this function. 5 minus 1 is 1. 1 squared is 1. 1 times a half. A half minus 8.
Negative 7.5.
Negative 7.5. Okay, so I'm going to say Emily has an inaccurate number. Can I ask you how you got -4, Emily? Just want to follow your train of thought. Where did it come from?
Were to turn fraction like 8 over 10 1/2. Then it'd be 2.
Okay, wait, say that again. I did not follow that. Okay, say it one more time.
Turning -8 into fractions, -8 over 1
Okay,
times half.
so that's 4.
But you were subtracting.
Oh. Okay. So you found your mistake? Okay. So did anybody get 5 and negative 7.5? Okay, so what was the other point you got when you got that one? 3 and negative 7.5. Okay. So let's see if I can draw this. 5, 5, 5, hold on. Negative 7.5. Oh, that's so close. Oh gosh, that's not beautiful. Looks like a dying dog. Let's pretend that looks better. Okay, now did anybody get other points than those two? Okay, hold on. Jaden, what'd you get?
I got
6, negative 6. Now I'm going to put a question mark and see if Jaden is right. Okay, so if I was going to verify this, I would plug the 6 in. Whoops, I went too far down. There we go. Okay, so 6 minus 4 makes 2. 2 squared, 4 times a half, 2 minus 8. Negative 6. So is she right? Yes. Now, did you do it that way? Did you plug and chug?
I kind of went up 4. Or, well, like,
You kind of?
I did 4 divided by 2, which is, or 4 times a half, which is 2, and so then I went up to.
Up to, whoa.
It's,
That kind of hurts
the-
my
it's
brain a
the-
little.
Yeah.
Hey, what's up, Miss Ruff? You look perplexed.
Oh,
You okay?
no, I'm great. I was just thinking.
Do you got a challenge problem for us? We can take a break.
Fatty acids?
What?
Fatty. It's a
Fatty and skinnies.
Oh,
We're doing
Wide and
fatties.
narrow?
Yeah. Sorry, multi words. They're very descriptive.
fatty and narrow. You guys are good with
I
that.
actually say skinnies.
They're quadratically proficient.
Do you got a
Was
question?
she using the 1, 3, 5,
Yeah,
7?
that's what I was using, but I just.
Yeah.
She was increasing by 1, 3, 5, 7.
Yeah, but the slope is 1/2. The A is 1/2.
Yeah.
Yeah. So I mean that's a lot of mental
She
breakage.
crushed that.
Yeah, that was tough.
That was tough.
That's tough. That's very good. See, I would have gone with the first part where you just go up a half over 1 part. That would have been simple in my brain, but she made it harder.
I like
But it was nice
graphing.
whole numbers.
So up 1 over 2 is only good for the first one,
Doesn't work though. Up 1 over 2 doesn't work.
right?
Right. That's where I was gonna go. I was hoping somebody did that, but nobody did. Did anybody do that?
Do a linear function.
Up 1 over 2?
Quadratic.
Did anybody do that? Nobody's gonna raise their hand now.
Nobody's gonna raise their hand now. Like, no, we didn't do that.
Did anybody go up 1 over 2 from our vertex? Up 1 over 2 and give me a point of 6 and negative 7?
Bad.
Nobody did that? Good job. Good job. Good. I'm glad you didn't even think that because there was a lot of people who did it in the last class. So what was the other point that correlated with 6, negative 6? 2, negative 6. Perfect. Okay, Ms. Ruff, what do you got for us?
Nothing, I forgot what I came into, that's why I was doing it. So.
So we need to give you a
Just
minute?
keep rolling, Nolte,
Okay.
and then I'll leave you a note when I remember.
Okay. All right, so can you go the other way? If I give you this graph, can you write the equation of the graph?
Yeah.
Okay, let's start with the easy pieces. What's the vertex? Careful now, look at the scale. 3, 6, okay, so 3, 6, this one goes by 1s, this one goes by 2s, so 3, 6 is our vertex. Careful, they'll always try to trick you with that. Not always, but sometimes. Yeah, do you see it? So the y is going by 2s. Okay. Okay, so 3, 6. So is it a max or a min? Max. Okay, which tells us what? That the a is negative. Okay, so keep that in your brain. The a is negative. Okay, write the equation. Can you write the equation? Someone's telling me it's 11. Okay. Heads up on that. Now, I'm thinking you might be getting a little stuck. I could be wrong, though. You guys are really smart. Okay, so if I'm given a vertex, I know the vertex, I'm going to start with the vertex form, right? Okay, so in the back of your brain, you're kind of going, okay, vertex form is a times the quantity x minus h squared plus k. Okay, I know the vertex, so what can I plug in? The vertex, the h and the k, right, literally? Yeah. Okay, so I can say that I know that at least it's going to be a times the quantity of x minus 3 squared plus 6. So the piece that I am still not sure about is the a value. How do I find the a value? You do. Yeah, you do some stuff. Okay, what? Very good. Okay, so give me a very beautiful plotted points. What?
5, 2.
Oh, 5, 2. Oh, I was looking at this one, but that works too. 5. So this is the point 5, 2. Okay, so when I say the point 5, 2, what are the two variables that are directly related to 5, 2? 5 is the x, and 2 is the y. Or in our case, the f of x, which is the fancy way to say y. Okay, so what do?
Put it into the equation.
You put it into the equation. You just literally plug those numbers in, and then we can solve for the a value. Okay, so my f of x is 2. The a value we're still determining. The x value from the point up there is 5. So 5 minus 3, the rest of this I'm just copying down. Awesome, I have an equation, I can solve this. What do I do first? What? Okay, so 5 minus 3 makes. Can I do 2 steps in one and just say 5 minus 3 is 2, 2 squared is 4, and just call that 4? You guys follow me. I'm going to go up here because I'm kind of running out of space. So I got 2 is equal to a times, what was this, 4. I really hate that it says a4. I really want to write that as 4a, but since it's on that side, I'll leave it there. Okay, what do I do next? Subtract the 6, good, so I subtract the 6. So it's 2 minus 6, negative 4. I'm going to write 4a this time because it makes me feel better. Okay, what's my last step? Divide by 4. So who has the a value? What is it? Negative 1. Okay, which maybe we could have made an educated guess and guessed that it was negative 1 by just kind of going, ooh, 1 unit to the right looks like about right there, and that's clearly 1/2. That would have been a good guess. But I like this way of proving it for sure. Okay, so what's my equation? F of x is equal to the a value, negative 1. Now, should I say negative 1? You don't have to. What's the cooler way to say it? Just negative. Now, would I mark you wrong if you said negative 1? No, I wouldn't. I'm not that mean. Okay, so then x minus 3 squared plus 6. Okay, did everybody follow that? Okay, that's definitely the hardest part of this lesson. So if you got that, you are golden. Good. Okay, how is everybody doing? Do we need to take like a break, stand up, shake it out a little bit, get a drink? Yes, no? You guys just want to keep going? Keep going? No shaking? Who wants a break? Oh my God, somebody say something.
Sure.
Sure what? Take a break. Whoa. All right, so the second half of this is going to be working with standard form. Okay, so we graphed all this stuff in vertex form. It was super easy, very literal. Okay, so now we're going to work with standard form. Okay, so standard form. This is what I would write down in your notes. Okay, standard form looks like this. Standard form. Okay, goes ax squared plus bx, whoops, plus c. Okay, so it looks very different from vertex form. There's no like quantities, there's no parentheses. It's just straightforward, quadratic, linear, constant terms. Okay, so that important point that we need to find, that vertex. How are we going to find the vertex? Okay, so do you see this down here? Can you see that? It's kind of small from probably where you're sitting. Okay, this is how we find the vertex. Okay, this is what I would probably write down if I were you. The h. You're going to use this fancy little formula, and it goes negative b over 2a. Okay, so you do a little formula. Okay, do you guys see this notation over here that says f of negative b over 2a? See that? What does that mean? Anybody seen that notation before? Mathematical notation? It's like f of x. So what do? Ah, yeah, you just plug it in. I always sing a song right now. Plug it in, plug it in. No? Okay, so the k. The definition is going to look like this. F of h. The function of h. So I'm just going to literally plug in whatever I get for the h. Okay. Okay, so let's do an example. Let's see if we've got one over here. No, okay, I'm going to make one up. Example. Y equals 2x squared plus 8x minus 3. Okay, so let's start with the h. How do I find the h? So it says negative b over 2a, right? So what is my negative b value? Negative 8. So negative 8 over 2 times the a, which is 2. So would everybody agree that negative 8 divided by 4 makes an h value of negative 2? So the h is negative 2. Now let's find the k value. How do I find the k value? Yeah, good. I'm just going to take that negative 2 and I'm going to plug it into the x of my equation. Okay, so I'm going to write it as 2 times negative 2 squared plus 8 times negative 2 minus 3. Okay, now I'm just going to do a little chug. Negative 2 squared is 4. 4 times 2 is 8. So I have 8 on my first term. And then I have plus 8 times negative 2.
Nolty, can you please send Jay Dillon to the office? She needs to check out for an appointment.
Yep.
Thank you.
So you could say plus negative 16. I personally like just minus 16. And then we have that minus 3 at the end. So 8 minus 16 is, and negative 8 minus 3, negative 11. Okay, so the vertex would be negative 2, negative 11. Okay, so let's say I asked you to graph this. Oh, worksheet assignment's right there. Okay, so I would graph this, right? So I graph the vertex. Negative 2, negative 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Holy buckets, there we go. Beautiful. Now, I need an a value, right? What's my a value? Yeah, it is literally the same a as from your standard equation. Okay, so the A is 2. Everybody okay with where we got that 2 from my equation up there? Okay, so I'm just going to go slope of 2. I'm going to go up 2 over 1. Boom, ba-doom, boom, boom. Let's label this so I got negative 2. Negative 11 is my vertex. What's this point over here on the right? If I went up 2 over 1. Negative 1, negative 9. Good. What's my one on the left? Negative 3, negative 9. Draw my beautiful. There we go. Ooh, that's good. Awesome sauce. Do I need to do another example of how to find the vertex from standard form? One more? Okay, can I just do one more of like just find the vertex and then you're okay with the graphing part? Okay, let's take number 6 right here and I want you to find the vertex. Okay, I'm going to give you a second. I'm going to put down my tablet. I'm going to take a sip of coffee, stretch my legs out while you guys do that. Okay, so find the vertex. How'd I do? Anybody else get negative 2, negative 31? Oh, whoa. That's a good question where I came up with 31.
You just like totally dropped it.
Fine. Okay, how about... Whoa. So negative 16 plus 1. Let's try that. Negative.
There we go. I did get that.
Good. It's a good thing you guys are around to check my math. Okay. So anybody have any questions on that?
How you got it?
Negative 31?
Yeah.
Well, let's see. I kind of ignored the 16 in the front. Okay. So the last piece of information here is they're going to ask you potentially to go from vertex form to standard form. Okay. So I'm going to just kind of show this to you and then we will do an example. Okay, so if I look at this, the vertex would be what? If you're looking at the top. 1, negative 4. Okay, with the slope of 2. Yeah. Okay, so what did they do on the first step? Here, let me kind of go like this. No cheating. What did they do first? Okay, so yeah, if you have a quantity that is squared, you basically have two of them. So they expanded it, they wrote it out. So what would you have to do if you have two quantities that are being multiplied by each other? Distribute. And what's the fancy little acronym for when you have to distribute two quantities together? FOIL. Okay, so they FOIL. Do you remember FOIL? Firsts, outers, inners, last. Okay, so that's how they get to this piece right here. Okay, that's the FOIL. Then what do they do next? Okay, yep, they distribute the 2 through. And then what's their last little piece? Combine like terms. They add those constants together. Okay, so I want to go backwards just a little bit. I want to talk about some foiling. Okay, so let's pull some stuff. Let's go, this will be the perfect spot. Okay, so foiling. If I have, let's just say x minus 5 squared. Everybody agrees that this is the same as x minus 5 times x minus 5. Okay, so if I FOIL this, first, x times x is x squared. Outers, x times negative 5. Negative 5x. Innards, negative 5 times x. Negative 5x. And negative 5 times negative 5. So then we add our like terms and it becomes x squared minus 10x plus 25. Okay. So since you guys are all like super mathy nerds, I mean awesome people, I want you to be able to go from here to here in one step. Okay, so let's see if you can figure this out. Let me do another one. I'm going to go straight there and let's see if you can figure out what I'm doing. Let's say I have x, whoops, not squared, sorry, x plus 3 squared. Okay, that's going to become x squared plus 6x plus 9. Got it? Okay, what if I do x minus 7 squared? What would that one be? You tell me. Ooh. Minus. And then, yep, the last term will always be, oops, 49. Always be positive. So can somebody give me like a how to do this if you were explaining this to somebody outside this class? Okay. Okay, yeah. Basically, you just add them, right? So to get the middle term, you just add whatever that number is, 7, right? So negative 7 plus negative 7 is negative 14. To get the last term, you multiply them. Okay, trick question. Maybe bonus question. What if I have this? 3x minus 2 squared. 9x
Minus 4.
squared. 9x squared minus 12x plus 4. Okay, do you see where each term is coming from? Okay, first term is the first one, basically squared, right? 3x times 3x. How do you get the middle one?
Multiply the first term by the second term.
Close. Times it by 2. Okay, so to get the middle term, you multiply the first times the last, and then times 2. So 3x times negative 2 is negative 6, and negative 6 times 2 is negative 12x. And the last one is just simply the last one squared. Okay. Okay, so now that we're experts at foiling, Let's go from vertex to standard form real fast. Let's choose red. Okay, so let's pretend, I don't know what number we're on, like 18 or something? No, 8. Okay, so let's say we had y equals negative 3x minus 6 squared plus 2. Okay, how would I take this vertex form and convert it to standard form? What would I do first?
You expand the 6 or x minus 6.
Okay, so can I do the quick version and just go straight to my FOILed version? Okay, so we just did that. So what does x minus 6 squared become? X squared minus 12x plus 36. And notice that I kept that in parentheses, because what is my next step? Distribute. Okay, so if I distribute the negative 3 through, I get negative 3x squared plus 36, minus, oh good lord, 3 times 36 makes 108? 108. And last step? Plus the 2. So negative, let's see if we can add a negative today. 36x, negative 108 plus 2 is negative 106. Do we agree with that? Phew. Okay, so that would be your standard. Awesome sauce? I feel like I'm saying that today a lot. I need to change that. Any questions?